All right. So we're going to start here. We need to talk about rate of change before we get into this unit deep. Okay. So your formal definition, the ratio that compares the amount of change of the dependent variable to the amount of change in the independent variable. When you think about linear functions, how is my linear function changing? What term do we use?
Y.
Okay, y equals, that's your equation. What value in that equation, though, makes your line change? M, which is what?
Slope.
Your slope. So guess what rate of change is? That's another fancy word for slope. So rate of change is just another word for slope. So a lot of this is going to be review. We are going to focus more on what in the world does it mean. When I tell you the slope is 2/3, what does that mean? What's changing? What's happening? So not only do you have to give me the value of slope now, you have to interpret the meaning behind it. Okay, so when you see this as a number, you'll see a little triangle. This is a Greek symbol called delta. Okay, when they use delta in math, it means change in. Okay, so we write this as the change in the dependent variable over the change in the independent variable. Okay. Again, that stands for delta, which means change in. Okay. They use a lot of Greek symbols in math. You have to be able to decipher what that Greek symbol means. Okay. So the top needs to be the change in my dependent variable. Well, what's my dependent variable? Which variable is dependent? Remember, which one was my input versus which one was my output? Okay, if we go to input and output, dependent is the same as my output. Which variable was my output?
Y.
Your Y. Okay, so let's change this from change in dependent. So the change in the output, which means on the top, I'm looking for the change in Y. So all of these things are equivalent, which means what? What does equivalent mean? Equal. Okay, think about the beginning part of the word. Equiv. Looks like equal. Okay, so on the top, I want to put the change in my output or the change in my Y. So in the bottom, we want to put change in the input or the change in our x. Okay, ladies, conversation needs to stop. This clues in on page 30. Okay. Change in your dependent over change in your independent, which means change in the output over change in the input, which means change over y over change over x. Page 30, page 29 should be yeah. Okay, I do believe the color is still red up here, and I hear a lot of talking. I will gladly start my homework board, and every time I have to address you, your name goes up on it. Every time your name goes up, it's 15 minutes of detention that must be served before a write-up. You don't serve it, you get written up. Please don't make me do that. Okay, there are 4 different types of slope that you can see. The first one is going to be a positive slope. So, give me an example of a positive slope. Okay, a line that goes up to the right would be a positive slope. Okay. So, any line that's going to go up and to the right has a positive slope. This means that your change in y is positive and your change in x is positive. Okay? It's going up as it goes to the right. Okay? Negative slope. If positive slope goes up to the right, what does a negative slope do? It goes down to the right. Okay? So, in a negative slope, the change in your y is going to be a negative number because it's going down. And the change in your x is still going to be a positive number. Why are they not both going to be negative? What does a negative over a negative make? Positive. It makes it a positive. So if we made both of our changes a negative, we'd actually have a positive slope. Okay. So as your y is decreasing, your x is increasing with a negative slope. Questions? Okay. We have two special slopes. The first one would have a slope of 0.
Wouldn't it be like this?
Good. That's fantastic. Okay. Sabi says if I have a 0 slope, I have a horizontal line. So a 0 slope is a horizontal line, which means we have y equals a number. Okay. So anytime you see y equals a number, that is automatically a horizontal line. Okay. Your slope is 0. I even gave it to you above the door. Okay. It says horizontal. The top of the door makes a horizontal line. Right above that, I have y equals. To get you into the habit of anytime y equals a number, that means we have a horizontal line. So y equals 2 is a horizontal line at 2. Y equals -3 is a horizontal line at -3. Okay, so 0 slope goes horizontally, which means an undefined slope is going to go up and down. These are your vertical lines. So anytime you have something that says x equals some number, that is a vertical line, which means you have an undefined slope. This slope is undefined because your change in x is 0. And one of the biggest things in math is you cannot define. So anytime you see x equals 3, that's a vertical line at 3. X equals -7 is a vertical line at -7. Questions? Okay, that clues in on page 31, and we're going to get into some work now. Woo! You want to do graphs or tables first? Tables? Okay. It doesn't matter. We're going to cover them both today. Okay. Okay. Find your paper that says calculating rate of change from a table or a set of points. All three of them are going to be 132 when we're finished. They fold up into those little booklets. Okay. Remember, to calculate slope on the top, I need to figure out how does the change happen in Y? Okay, how does the change happen in Y? So, Y starts us off at what in my table? Y. 14. This is your Y. So what's happening if I'm going from 14 to 21? Adding 7. I'm going from 21 to 28 plus 7. I'm going from 28 to 35 plus 7. Okay. So every time my Y changes, it's increasing by 7. So that's your change in Y. So your top number should be a positive 7. In the bottom is your change in X. What's happening every time my X changes? We're increasing by 1. Okay, so would you say that this slope is positive, negative, 0, or undefined? This is a positive slope. Well, what in the world does this mean? You've got 7 over 1. So you know your slope is 7 over 1. What does that mean?
7 is for Y.
7 is my Y. But what does that mean?
That's how much.
What's changing though?
Y.
Your numbers?
What was that?
Every
mile you're charged what?
$7.
$7. So you're charged $7 for every mile traveled. That's what this means.
Oh, yeah.
For every mile, you are charged $7. Okay. For every mile, you've been charged $7. So if I tell you you've traveled 15 miles, what would I do with 15 to find out how much I'm charged? 15, what am I doing with 7? Multiplying. You would take 15 times 7 to figure out how much money you would be charged to drive 15 miles. Questions?
Okay, so you go back home. Okay, go back home.
You good?
Yeah.
Okay, this time I've taken your chart or your table and I've moved it horizontally. So I need to find my change in y. What numbers do I need to look at to find my change in y? The length of the spring is your y. In a horizontal table, your y is the bottom values and your x is in the top. What is my change in my y? 0.8. So 0.8 divided by, what's my change in my x? 0.5. Can that be reduced? Can 8 over 5 reduce? No. So we should leave it alone. Is this positive or negative? Positive. Okay. Think about it for a minute and think about what this means. Think about what this means. Who wants to interpret and tell me what this one means? Somebody other than the same people that like to answer. Don't make me just start picking names.
Oh, yeah.
I mean, someone other than the people that always like to answer. Oh yeah, I think you want to do it since you like to volunteer everybody else. Okay, so think about what's happening in your y. 0.8, which means it's doing what? Because it's positive. Is it increasing or decreasing? So it's increasing. What's increasing in your y? What are we talking about in your y? Okay, inches. So every time your spring increases by 0.8 inches. Okay, so your spring's increasing by 0.8 inches. What's happening to your weight then? What's your weight increasing by? You're changing x. 0.5. So every time your spring increases by 0.8 inches, the weight is increasing by 0.5 pounds. Okay. So the spring increases by 0.8 inches, while the weight increases by 0.5 pounds. Okay. The spring increases by 0.8 inches, while the weight increases by 0.5 pounds. Yes, sir. I'd really rather you not go in the middle of notes. If you actually divide this out, you end up with 1.6 divided by 1. So it's increasing by 1.6 inches per pound. So if you actually take 0.8 and divide by 0.5 to get an actual number, you get 1.6. which means the length of my spring increases by 1.6 for every pound that I put on it. So think about it. If I take a spring and I'm adding weights to it, it's going to make my spring get bigger and bigger and bigger. The more weight I put on it, the more strain it's going to put on that spring. Point 0.8 divided by 0.5. Because think about it. If 1, you have to 2 times 0.5. 2 halves make a whole, right? So 2 of 0.5 make a whole. Well, then 2 times 0.8 is 1.5. Y'all don't like decimals or fractions for any set of reasons. Oh, I don't have time to wait. We need to move on. Okay, this time, they don't tell you what your X is. They don't tell you what your Y is. We need to figure that out from the word problem, fill in the table before we can find your rate of change. So it says Vance is doing an experiment breeding fruit flies for his biology class. At 1 p.m., he counts 100 fruit flies in a box. At 4 p.m., he now has 370 flies in the box. Calculate the rate of change. What do you think our independent variable is? What does he have control of? He has control of the time. He can't control how many butterflies that they make. He can control the time. So your time is going to be your X. Guys, no offense, but with that Unit 1 test results, y'all might want to pay attention a little bit more and talk a little less. Because if you think those were good, they weren't. And yet I still hear conversation. For what reason, I'm not sure. So your time is your X. That's what you can control. You cannot control the fruit flies. So at 1 o'clock, it said we had 100 fruit flies, and at 4 o'clock, we had 370 fruit flies. We need to calculate the rate of change. So what's my change in Y? 270. My change in Y is 270. What's my change in X? 3. Okay, this is also positive. What's 270 divided by 3?
100.
What is 27 divided by 3?
90.
It's 9, which means 270 divided by 3 is 90. So 90 over 1. Well, what does this mean? 90 over 1.
For every hour he gains 1
For every hour, he gains 90 fruit flies. There are 90 fruit flies born every hour. Okay? 90 fruit flies born every hour. So this is fruit flies per hour. Okay? The income of a rural population of Mississippi is increased from $22,657 in 2004 to $22,983 in 2005. Calculate the rate of change. What do you have control over?
a year.
The years. How long? Okay? How long has this happened?
2004.
Okay? So my X's are 2004 to 2005.
It increased by $300.
Okay, so we have control over the years. Well, what's my Y then? My money. My per capita income. So in 2004, it was 22,657. And in 2005, it was 22,983. Change in Y over change in X. What does my change in Y look like? You said what? No. No. What am I going up by? 300. No. 326. Good, Daniel. 326. And my years increasing by 1. Okay, so we've got another positive rate of change. What does this mean? Okay, so for every year, Xavier says for every year, your income's going up by $326. You think that's good?
No.
No.
Oh, wait.
Oops. Okay, so for every year, the income increases by 326. So let me get through these next two and you can run to the bathroom before we start the next one. Okay, take a look at your next one. My change in Y is what?
20.
Subtract 20. My change in Y is what? Plus 1. Uh-oh. Now we have a negative slope. What does this say? What does this mean? What is happening? For every payment, the balance is doing what? Decreasing by $20. Okay? Every time you make a payment, your balance, your loan balance is decreasing by $20. So for every payment, the balance decreases by $20. Well, does that make sense? Yeah. If you're making payments, your balance had better be going down. Because if your balance is going up, I don't know. I'd be questioning that loan company just a little bit. Last one. Bless you. A bookstore's retail sales at the end of 1996 were $500,000. By the end of 2000, the retail sales have increased to $600,000. Calculate the rate of change. Okay? So, is that my Y or my X though? That's my Y value. Okay, so my money is my Y value. So we started at 500,000 and we went to 600,000, which you said was an increase of 100,000. I don't know, we'll find out. Change in Y over change in X. So you said my top number should be 100,000. Okay, well my X is going to be my time in years. Okay, well what year did I start at? 1996. And we finished off at 2000. What's my change in X? 4. So we actually need to divide 100,000 by 4. 25,000. Okay? So now, what does that mean? For every year, we're increasing by 25,000. Okay? Every year, sales have increased by 25,000. Rizzo, as soon as you get this written down, you may use the restroom. Oh, sorry. 100,000. Okay. Quickly fold that one into a book. Glue it in on page 32. Make sure you leave room on there for 2 other books to fit. You've got 3 total books to go on there. We're going to do the next one together, and the last one's going to be your homework. Okay? I need you to listen carefully because I have changed some things. We are getting a sad amount of homework back in here. So from now on, every homework assignment you do not turn in, it is homework detention. And homework detention is going to happen on Tuesdays. You do not get to turn in your late assignment until you have served homework detention. So your grade will remain a 0 until you have served your time. So you need to start doing your homework in the evening. I do not give a lot each night.
What would you do when I do it? But you try.
I can accept that. But I'm getting complete blank. I didn't even look at it. I could care less. And I'm not handling that very well. Because that's just lazy. Yes. Make sure you leave room for 2 other booklets at the same time. These 2 over here are full of giggles today. Giggles. Graph. From a graph. Doesn't matter as long as you're gluing in the blank side and you can open it up and see everything on the side. Yeah, I'm not picking it. Okay. Okay, when I'm looking at a graph, okay, I still need to find the change in y over the change in x. Okay, I want you to pick 2 points. It doesn't matter what 2. So, somebody give me a point on the graph.
I hate graphs. 1, 2.
You said 1 comma what?
15
No, 1, 5.
1 comma
15.
15. Okay, so this is 1 comma 15.
Oh, you got 0 cents too.
Okay, I also have 0, 10. Okay, so pick 2 points. Okay, we picked our 2 points. You told me 0 comma 10, 1 comma 15. Okay, my y is changing by what?
5.
Wait, 10. 5.
It's changing by 5. My y is going from 10 to 15. So it's changing by 5. My x is changing by 1. It's positive. You can tell that by the graph because it's going up to the right. What does this mean?
For every hour you're ready,
Okay, for every hour. For every hour. your rent increases by $5. Okay, so this is kind of like if you're renting, I don't know, a lawnmower. You know, you can go to the grocery stores and you can rent one of those carpet scrubbers and they charge you to rent them. Okay, this is not like apartment rent, is what I'm getting at. Okay. Just mind your business, Brenda. If they charge you rent for a car per hour though, I don't know, that's kind of, I don't know if I'd rent that car. That would get slightly expensive. Okay? Change in Y over change in X. This time they marked the 2 points that they want you to use. So, what's my change in Y? Okay, it's going from here to here. So it's not just 12, it's negative 12. This is a negative slope. So negative 12. What's my change in X's? It's positive 4. It's going from 2 to 6. Okay, so it's a negative slope. What's negative 12 divided by 4?
3.
Negative 3 over 1. What does that mean? What does this mean in terms of my graph? For every time, which is in what? My time is in what? Whoa, listen to what I'm saying. Time is in what? Seconds. So for every second, what is happening?
Your height decreases by 3.
The height decreases by 3 what? 3 what?
2 feet.
Feet. Okay, so for every second, the height decreases by 3 feet. Okay. For every second, the height decreases by 3 feet. We're on calculating rate of change from a graph. If you don't get these 2 right away, that's fine. And I'll give it to you when we're finished so you can get these 2 on there. Yes, yes. In the middle of notes, I don't
Like,
quickly.
back where it say, something like,
We just finished this one. So we're gonna flip to this one and then I'll give you mine.
but it's still.
Yes.
Here, it don't, like, you don't have to say every, I may be looking at something. No.
The height decreases by 3 feet. Okay, this one doesn't give us 2 points. Whoops, wrong one, my bad. Right here. This one doesn't give us 2 points, so we have to pick 2 points.
2 is
2 comma what?
2 comma. Wait, 1 comma 2.
1 comma 2, okay.
And 2 comma 3.
2 comma 3. Okay, Savage. There he goes. 2 comma 3 and 1 comma 2. What's my change in Y? 1, it's going from 2 to 3. What's my change in x? 1, it's going from 1 to 2. So 1 over 1. What does this mean? Positive slope. Excellent.
Weight of bucket.
Okay. Weight of bucket. That is our y. What does this mean? Take a look at what we're looking at. For every what?
For every pound of sand.
For every pound of sand, the weight of the bucket increases by 1 pound. Okay, so for every pound of sand, the weight increases by 1 pound. Okay. I started the shorthand with an up arrow instead of increases. Okay. So for every pound of sand that you put in the bucket, the weight of the bucket increases by 1 pound. Well, that makes sense. For every Miss Smith you put in the bucket, it increases by 267. It may sink to the bottom of the ocean at that point. Hey, at least I got her to laugh today. Okay. Scoochie. Okay. I don't like the ones that they gave us. They're hard. Let's do this one here, which is 0,70. And let's do this one here, which is 30,30. Okay. My suggestion to you, when you're doing slope from a graph, make sure that you are picking points that you can easily identify. Okay. Don't pick one where you have to guess where it's landing if you can avoid it. Some of the graphs, you will not be able to avoid them, but try. Okay. So what's my change in y? Decreasing by 40, so negative 40. What's happening to my x? It's increasing by negative 40 over positive 30. Okay, that's 1.33 over 1. Negative 1.33 over 1. Yes, it's negative, which means it's decreasing. Okay. So this means for every hour, I heard somebody say it, the volume is decreasing by negative 1.33 thousand gallons. So, am I letting water out or am I putting water in? It's letting out. Okay, my water's letting out. Okay, for every hour, the volume of water is decreasing by 1.33 thousand gallons.
Go down. Wait. No. Third period.
Okay, this one. I marked 2 points, 0,25, as well as 50,175. Change in Y is what? What's my change in Y? What is my change in Y? What value is my change in Y? I'm going from 25 to 175. Increase by 150. What's my change in X? 50. When I divide that out, what do I get? 3/1. What does that mean? I'm assuming that's in pounds. So every pound, we're charged what? $3. Okay, so for every pound, we are charged $3. Okay.